All right, we're talking about the get function as it relates to dictionaries. So again, dictionaries are not indexed. That means you can't search them or access them using the 0, 1, 2, 3 of the location, right? So it's possible that a user could search for a key that doesn't exist, right? So when that happens, that's going to return something called a key error. The compiler can't find the key that matches a search term, so it kicks you out of your program. And that's something we don't want, right? Because it's a very common thing that you're looking for something that doesn't exist. So to avoid this, we actually use the get function. And that's either going to return the value. So if you try to get a key, it's going to return the value that's supposed to be there. But if there's not a key, then it returns whatever value the programmer tells it to return. Sometimes it just returns none. But you can make it return whatever you want. So if you think of it like an if-else statement, if the key exists, return the value, else return an alternate value. So if you don't put in an alternate value, it's just going to return none. But it's still going to prevent an error. It's going to let your code keep running. So sometimes you don't want to give any feedback to the user necessarily. You just want to keep rolling. So you can do that with the get function as well. So here's some examples of the get function. So I made a translator. Red is the English, rojo is the Spanish, blue is the English, azul is the Spanish, whatever. And forgive my pronunciation, but that's kind of the concept of it. Now, if I'm trying to print my translator dot get purple, this is going to return none because purple does not exist. Now, if I just tried to print my translator square bracket purple, then it's going to give me an error, right? If I just tried to print this right here, it's going to normally give me an error because it doesn't exist. So the get actually prevents that error, but it just returns none. So it doesn't give you any extra information. Now, in this example, I've got the same translator. Purple still doesn't exist, but I'm going to get it, and then I'm going to return the information. This color is not included. So what happens when we run that is it looks for purple, it says it's not there, and then it gives the feedback to the user that says this color is not included. Now, this is with get, right? You can do a very similar thing with an if statement, because again, when I was talking about the get, it's basically an if statement, right? But you can do this same thing. You could say if purple in my translator. So remember, we use the keyword in, and that looks through the entire list. You can also use it with tuples. You can also use it with dictionaries. It looks through every key in the dictionary to see if it can find purple. If it can find purple, then it tells you, in this case, it just says that color is translated already. You could also print my translator purple. But if it's not translated already, if that means it doesn't exist, if it can't find it, then it's going to kick down to the else, and then you're just defining purple as morada, which is, again, English and Spanish. So we're doing a lot in this one statement, right? We're doing an if-else. We're using the in keyword, running a simple print, but we're also declaring a new key and giving it a value. Remember, every key that you create has to have a value associated with it. You can't have a key without a value. You can't have a value without a key. So just make sure that when you're adding a key, you always give it a key name and then a value associated with it. The next thing I want to talk about is this idea of items. So this is something that's on the syllabus and goes through, so we just need to talk about what it is. The items function, what it's going to do is look at all the pairs in a dictionary, and it's going to store them in some variable or store them in it stores them in their current state of the dictionary. Not necessarily the state that the dictionary was in when the items function was called. So what the items function does is it looks at the dictionary and it prints out or gives you the opportunity to print out each individual key pair. So in most cases when we're making a key pair, it's going to look something like this. 1:1, 2:2. But when you're using the items, it's going to print it out more like a tuple, more of the parentheses, comma, the other item, right? So the parentheses, this is going to be the key, and this would be the value if you were using the item. So what I want you to do is just go through and kind of copy this code and see what it does. The cool thing about it is that even though we're setting X equal to items up here, when we change the items down here and we print just X again, it's still pulling just all of the items from the dictionary, so it's not going to store the values here, right? It's not storing the values of instructor items, it's storing the function instructor items, so then it pulls it and it's a different set when we print it down here. And I think that's a pretty cool application. There's not a lot of stuff that we can do that with, but it's cool the way that it goes. All right, so we want to go a little bit of a summary around lists, tuples, and dictionaries because we have talked about all of these, right? So list is going to use a square bracket. Square bracket, and it has elements, and all of the elements have to be the same type. You can use strings, integers, floats, booleans, but they all have to be the same. A tuple uses parentheses. And the elements don't have to be the same. They can be anything. They can be the same, but they can be anything. The biggest difference, my list can be changed, and my tuple cannot be changed. It's exactly what you set it as for the entire duration. And a dictionary uses the braces or the curly braces, the squiggle brackets, whatever you want to designate these as. But when you use a dictionary, you have to have a key and a value, and a key and a value. And every key has a value associated with it. Now, another way you can set the values in a dictionary, you can follow this formatting. The dictionary, you give it the name, and this is just like setting any variable, right? You have a name, and then you have the values you're storing in it. DICT is the shorthand for setting a dictionary, for the dictionary function in Python. So this function here is a pre-built function, and all it does is it creates a dictionary based on your values. Now, what that means is your key 1 doesn't have to be a string anymore. You can just type in key 1 and then value, key 2 value, key 3 value. It's recording this as the key. Right, and you don't have to make it a string up here either, I don't think, but it's good practice to make it a string. It's just easier for it to read. But when you're doing it this way, you don't make it a string. It just speeds up the process a little bit. Because you can add and remove, you can do different things with this, but the general idea is that you defining it this way or defining it using the MyDictionary function, these are exactly the same thing. They result in the exact same thing. And I don't have a discernible benefit to using one over the other. It's just preference. So my preference is this, just because it makes more sense to me. I'm making the variable name and then I'm assigning the values manually. This is doing the same thing. I'm just using a function to do that manual application, but I'm still having to punch everything in manually. So I'm not sure there's a benefit one way or the other. Maybe when you're using some variables or some different changeable things, then this might be more beneficial. But for the most part, either way is fine. Tuples do the same thing. There is a tuple function that allows you to set my tuple equal to tuple and then whatever the values are. The main difference is, of course, tuple looks like this, parentheses, elements, and close parentheses. Because tuple is a function, you're going to have a double parentheses on the front and the back when you run tuple. This is, again, it does the same thing as just setting tuple equal to the elements. I think this is a little bit more steps, so I don't really see a benefit to it. Seems a little redundant, but if you're more comfortable using this, then there's no reason not to. It doesn't change anything. I just think it's a little more work. There's a couple of terminology points we have to talk about. And these are definitely going to be covered on the exam. There's the idea of ordered and changeable, and whether it allows duplicates or not. So to be ordered in Python generally means you can access it via an index. So when the variable is created, everything is in a very specific order. And that order is not going to change, right? So you know that the item in index 4 is always going to be the item in index 4. That means that the variable type is ordered. So list and tuples are ordered. And previously, well, that doesn't matter. Dictionaries are ordered also, right? Everything's always going to be stored in the same location, but you just can't access them via indexes. But it does know, like if you're going to pop out a dictionary elements or dictionary key values, then it's always going to pop out the one at the end. It knows which order they're in, so it's always accessing the last one in the order. Now, there are some data types that are unordered. We don't cover them because they're not necessarily on the syllabus, but there are data types that are unordered, so you can't do things like change the index because it acts kind of weird sometimes. So the next terminology is changeable. To be changeable, that just means that items can be added or removed, and we talked about this with list. You can change a value, you can add a value, you can remove a value. With a dictionary, you can change a value, you can add a value, you can remove a value. But with a tuple, you cannot do any of that. You cannot reorder it, you can't change it, you can't add, you can't remove. The terminology that they use to oppose the idea of changeable is immutable. I don't know why they don't just use unchangeable, but they use the term immutable. So this is something that's going to pop up, and all it means is that it cannot be changed. So then they're going to ask you about what allows duplicates. And remember, lists and tuples, you can have duplicate values. You could enter the letter A for as many index locations as you want. But in a dictionary, each key is unique, and it can't be duplicated. So if you try to add a key, if you try to add a key that already exists, all you're going to do is overwrite the value of that key. Now, the values, you can have more than one value. The value for 6 different keys could be true, but you can't change the actual key itself. Or you can't have more than one of the same key. But they can change. But each key is unique, so you can't have the same key multiple times. So just as a summary, tuples and lists allow duplicates, and dictionaries do not allow duplicates. The last thing is a list can be made up of any data set. And we talked about that when we talked of lists, right? A list could be an integer, it could be a float, it could be a boolean. A list could be a list. We talked about that when we had the 2-dimensional list or the 3-dimensional list. But lists can also have tuples as their data set. They can also have dictionaries as their data set. A list can be made up of any of these data sets. We're going to look at some examples of this. Typing it out here looks kind of absurd. So I'm going to go over it as an actual coding example to show it. All of this makes more sense when we see it in action. So we're going to do an onlinepython.com where I'm actually doing the coding. And then I'm also going to go over the project for the weekend. It's just a couple of other videos that we have to go through. I know some people had some struggles with it. The last thing I want to talk about is the dictionary formatting. Most things in Python, almost everything in Python, is designated by the spacing, right? The spacing really, really matters. But in a dictionary, because it has the open and closed brackets, the spacing is a little bit more flexible. Now, a lot of times we're going to define it just like this, just because that makes the most sense, and that's something we're really comfortable with. But if you see it defined like this, where each key and value has its own line, that's acceptable too. It's one of the few things that is acceptable without the spacing in Python. So for consistency's sake, maybe just leave it like this, but just know that you can see it the other way, and if they present it like that on the exam, it's okay. And that's the end of this video.